In this video, let us look at a very interesting process of finding the inverse of a matrix using the concept of cofactors matrix. So we have already seen what inverse of a matrix is. So if you have a matrix A and a matrix B such that A into B is same as B into A is same as the identity matrix, we say that A and B are inverses of one another, and we denote B is equal to A inverse and A is equal to B inverse. So if you have a given matrix A, what is such a matrix which when post multiplied with A or pre multiplied with A always gives the identity matrix as the product? So if you can find such a matrix, that is called the inverse matrix. Now let us try to find the inverse of a matrix using the concept of cofactors. So first let us look at an example and then let us try to generalize the method. So let us take A as matrix 1 2 1 3 1 2 1 2 3. So let us take this as matrix A. So let us try to find the inverse. So to find the inverse, what I do is first let me calculate the minus matrix. So you have already learned what the minus matrix is. A matrix which contains the minus of the corresponding elements of A. So what is the minor of 1? 3 minus 4 is minus 1. What is the minor of 2? 9 minus 2, 7. What is the minor of 1? You remove the corresponding row and column, the determinant of the remaining matrix. 3 2s are 6, minus 1 is 5. Corresponding to 3, the minor is 6 minus 2, 4. Corresponding to 1, 3 minus 1 is 2. Corresponding to 2, 2 minus 2 is 0. Corresponding to 1, 4 minus 1 is 3. Corresponding to 2, 2 minus 3 is minus 1. Corresponding to 3, 1 minus 6 is minus 5. So this is the minus matrix. And what is the cofactors matrix? We have already seen that you have an into sign where the elements look intact. There is minus 1, 2, minus 5, and 3 and 5. These elements do not change, and the remaining elements change their sign. So 7 becomes minus 7, minus 4, 1 and 0. So corresponding to A, this is the cofactors matrix. And what is the speciality of cofactors matrix? If you take any row of this matrix and multiply with the corresponding row of the cofactors matrix, you get the determinant as the answer. Second row into second row, determinant. Third row into third row is also the determinant. And what is the next property? First row of A multiplied with any other row of A. Apart from the first row, if you multiply the first row of A with row 2 of C, you get 0 as the answer. Row 1 of A into row 3 of C gives you 0 as the answer. So if you multiply a row with a corresponding row, you always get determinant as the answer. If you multiply a given row with another row, you get 0 as the answer. We have already checked this. If you want, you can check it again. 1 into minus 1 is minus 1. 2 into minus 7 is minus 14. 1 into 5 is 5. So you get minus 10. Second row into second column, minus 12 plus 2 plus 0, again minus 10. Third row into third column, 3 plus 2 minus 15, again equal to minus 2. any row with another row. 1 into minus 4 is minus 4, 2 into 2 is plus 4, 0. Row 2 into row 3, 9 plus 1 minus 10 again equal to 0. So this is a very interesting property. Now what I do is, I try to multiply A with the transpose of cofactors matrix. So usually when you multiply two matrices, you multiply the corresponding row with the corresponding column of the cofactors matrix, of the second matrix. So what I now do is, I'll consider the cofactors matrix transpose. This is nothing but minus 1 minus 7 5 minus 4 2 0 3 1 minus 5. The row of this has become a column of this. The second row has become second column. The third row has become third column. Now what happens if you multiply these two? What is A times C transpose? If you multiply these two, if you multiply first row with the first column, this is nothing but the first row of this. So this into this gives you minus 10. Second row into second column gives you 2 element minus 10 again. Third row into third column again gives you minus 10. First row into the second column gives you 0. First row into third column also gives you 0. Second row into first row is 0, 0, 0, 0. So if you multiply A with the transpose of cofactors matrix, you get all the diagonal elements as the determinant of A and all the remaining elements as zeros. So can I write it as minus 10 times I? If you take out a minus 10, the remaining matrix is an identity matrix. So A times C transpose is equal to minus 10. This implies A times C transpose by minus 10 is equal to I. So A when multiplied by C transpose by minus 10 gives you I. So the C transpose by minus 10 is the inverse of A. And you need to keep track of these numbers. What is minus 10? Minus 10 is nothing but the determinant of this. And C transpose is the transpose of the corresponding cofactors matrix of A. So to find the inverse, it is sufficient if you know the cofactors transpose matrix and the determinant of the matrix. So let us try to do the same process in a general way. So let A be a matrix. So we have seen that A times cofactors matrix transpose is always equal to determinant of A times I. And if you observe closely, this also works in the reverse direction. So cofactors transpose matrix times A also gives you the same matrix. So you can look at it from the previous example. So this implies A times cofactors matrix transpose by det A is equal to cofactors matrix by det A times A is equal to I. So what is the inverse of A? A inverse is nothing but the cofactors matrix transpose of matrix A divided by det A. This is a scalar. Det A is a number. Is cofactors transpose matrix is being divided by this number or being multiplied by 1 by det A. So this is the inverse of the matrix A. And this cofactors matrix transpose is usually denoted as adjoint of A. So whenever I say adjoint of matrix A, we are talking about the transpose of the cofactors matrix of the matrix A. So what is the definition of A inverse? A inverse is equal to adjoint of A by det A. This is a very simple process to find the inverse of a given matrix. Adjoint of A by det A. Adjoint of A is nothing but cofactors matrix transpose. Now, you have a slight problem here. So, what is the problem here? A inverse is adjoint A by det A. If det A is equal to 0, inverse does not exist. That means all matrices do not have inverses. If det A is equal to 0, inverse does not exist. So we call such matrices as singular matrices. Singular matrices or non-invertible matrices. Non-invertible matrices. So if you want to find inverse of a matrix, first you need to find det A. If det A is equal to 0, you cannot find a inverse matrix. If det A is not equal to 0, then you can find a inverse of the matrix. Okay, and if det A is not equal to 0, we call it a non-singular matrix. Non-singular matrix or invertible matrix. Invertible matrix. So if det A is equal to 0, inverse does not exist. If det A is not equal to 0, then inverse exists. And this is the method to find the inverse of a given matrix. So if you have a 2 by 2 matrix instead of a 3 by 3 matrix, so there is a direct formula using the cofactors matrix for finding the inverse. For example, if you have a matrix A, B, C, D. So corresponding to A, what is the minors matrix? So what is the minor of A? You need to eliminate this row and this column. Only one element is being left. So what is the discriminant? What is the determinant of a 1 by 1 matrix? The element itself. So D, what is the minor of this? C, what is the minor of C? You get B. What is the minor of D? You get A. So this is the 1 1 element, 1 2 element, 2 1 element, 2 2 element. So what is the cofactors matrix? So cofactors by definition is minus 1 whole power I plus j times the corresponding minor. So if I plus j is even, minor is equal to cofactor. If I plus j is odd, you have to change the sign. So you can see that for these two elements, I plus j is even. So these two elements are intact. And for these two elements, I plus j is odd. So you need to change the sign of these two elements. So this is the cofactors matrix. Now, what is the adjoint of A? Adjoint of A is the transpose of this. There is a D minus C minus B and A. So what is A inverse? 1 by the discriminant of this. Adjoint of A by det A is the inverse. So if you have A inverse, 1 by, what is the determinant of a 2 by 2 matrix? AD minus BC. AD minus BC. So 1 by AD minus BC times D minus B minus C and A. So this is the direct inverse for a 2 by 2 matrix. So you don't need to do the work. So if you try to understand the formula, it is 1 by det of A times, so the diagonal elements have to be interchanged. So AD becomes TA. And the non-diagonal elements have to be changed their signs. So you just need to change the signs of these two, minus B and minus C. That is what you get as the inverse of a 2 by 2 matrix. So for a 3 by 3 matrix, you need to do some working. But for a 2 by 2 matrix, you have a direct formula for inverse, which you can use often if you remember this. So I urge you to remember this. And if you have a 1 by 1 matrix, if A is an element A inverse will be simply element 1 by A. A inverse is simply a 1 by 1 matrix containing the reciprocal of that element. So 1 by 1 matrix inverse is very easy. 2 by 2 matrix also inverse is easy. 3 by 3 matrix you need to work a little. Thank you.